We're recording and live on the internet. So, other reminders, we're gonna do math, I swear. Remember, this is review here. I just updated the grade book, so it now does not count towards your grade. So before, if you had done some of that, it was part of your grade. As of yesterday, I took that out, so it doesn't count. So only stuff that counts now is from 2.1 on.
Oh, well, I used some late passes on that.
On 2.1?
On chapter 1.
Okay.
So they're due.
Send me an email reminding me of that, and I'll give you those late passes back. Okay. Yeah, so that's another thing. If you ever use a late pass because you're thinking you're going to use it, but then you get it done on time, just send me a note, and I'll give you the late pass back. Okay? All right, here we go. Homework questions on 2.1 that I've received so far. It is due today. Number 7, I have several questions on number 7, so I just want to go over that with everybody. Anyone that clicks this problem, the graph will be slightly different each time. It's going to have the same shape, but the 1, 2, 3, 4 points that make it up are slightly different for each person. Okay, and every time I log in, it's slightly different. So keep that in mind, but the idea is the same. So I'm just going to go through this. Other thing about this, once in a while, I'm going to ask you to type me some sentence or sentences. The computer can't grade those. It can only grade a number or a function, something like that. If it comes to human interaction in words, I have to grade those. So anytime something is like that, it'll be a 0 until I go in and grade it. So don't think, oh man, my idea was totally wrong. It just means the computer can't deal with it. It's a 0 till I go in and look at it and say, yeah. And what will happen when I do that is in the grade book, you'll see there's a message attached to your grade, and you can see the feedback I provided, like yes, good answer, or this is what the answer should be instead. Or I might say, hey, think about this, and then resubmit that point. Sam?
So are you a complete sentences person or a short and sweet person?
For now, I'm going to let lots of things slide, but I prefer complete sentences in very, good written language.
Because I did not use a complete sentence.
Okay, so let's just try this one together. I'm going to copy and paste this into my magic whiteboard here. Copy. Pretty picture. And let's grab the questions. Okay, and some people found this question obvious, other people didn't. I did my best to try and make it descriptive, but not too wordy. So what's the formula used to calculate average speed? So we've talked about average speed the last couple of days. Average speed is total distance over total time. Underneath, I give you a little prompt that says use D for change in position or distance and T for change in time. So I'm basically saying that your average speed, which is the slope, change in the total distance, I'll call that TD, over change in the total time. I'm just saying call that D and call the other change T. I just wanted you to write, hey, it's D over T. That's what I was hoping for there. So if you already did this problem and you didn't get it right, go back, do it again. If you didn't do it yet, bonus. I'm giving you my answers here. Next thing we want to do is we want to use the graph to calculate the average speed for the first 5 seconds. So that would be this region of the graph right there. And you can see we started at a position of 3, ended at a position of 4, and it took 5 seconds to do that. So the rise there is 1, the run is 5. Sometimes when you click on a problem, it says type a reduced fraction or something like that. Other times it says enter a whole number or decimal. So pay attention to the fine print, otherwise it might mark your answer wrong. I can't remember what this one says. Enter a mathematical expression, and then it gives examples of mathematical expressions, fractions, exponents. You could even enter 2 plus 3. So in this case, I could enter 1/5, or I could type 0.2. Either one should be okay. Question?
What about units and then the column?
Yeah, we'll talk about the units here next. Yeah. So would you agree the slope there is 1/5? Y'all with me on that? All right, so we can see that pretty clear. The next thing, the question says, well, what are the units of that slope here? Well, the vertical change is in meters, right? And the horizontal change is measured in seconds, so the units must be meters per second. Okay, and so what I was hoping you would type here is m/s. Okay, and if you ever type something else and you think, I like my answer, and it marked you wrong, hit the message instructor and say, hey, I think my answer for this one was pretty good. And I'll take a look and say, oh, yeah, okay, I'll take that. And I can give you credit. Otherwise, feel free to regenerate it and do it again. Next one, we want to know what is the average change from 5 to 15 seconds, which happens to be this lovely horizontal part there. And what's going on there? It's just standing still, really. There's no slope there. Yeah, so there's no rise, 0, run is 10, which is 0. So there's no change in position. What are the units of that no change in position? It's meters per second again. Yeah, it is meters per second again. Yeah. Last one says calculate the average speed from 15 to 30 seconds. Switch colors, that would be this region right there. And I want to say, okay, well, how did we move? We had a change of -4 for the slope there. Right? We dropped 4 meters, and it took how long to do that? 15 seconds. And I think because it said enter a mathematical expression for the other one, we should be able to just type -4 over 15. Or you can convert that to a decimal, which this particular decimal is repeating, unfortunately, so a fraction is probably the better answer. It's again meters per second. So here we have this thingy moving along, right? It's got a positive speed and it stops for a little bit. What's that black part of the function telling us the thing is doing? It's going backwards. Yeah, it's backing up to wherever it started from, which is back before 3 meters where we started measuring it. Okay. So the last question says, explain the meaning of the slope between 15 and 30 seconds, and lots of ways you could word that. I have to go grade it manually no matter what you write, but something like it's moving backwards. It's going back to where it started, something like that. So I'm just gonna plug those answers in just to get some credit for my open math. You know the downside of the teacher view here? Although it'll grade me, it won't record it. So all evidence of me doing stuff vanishes, which is always slightly annoying. Meters per second, 0. Meters per second. -4/15, is that correct? For this particular version. And again, your version will be slightly different. And then the thingy is moving backwards. My version, and I probably should put a period in there since I told Sam I like my sentences, and submit. And I should get everything but that last part right. And again, because it's manually graded, the system is waiting for the teacher to go look at it later. Okay, so for people that have done this, some of you I've already graded them, but I haven't graded everybody's yet. I will do that tomorrow once people turn it in. All right, there was another question. 9? Yes, 9 came up. So let's take a look at this one. I did a problem kind of like this on day 1. We've got a table here of time in seconds and velocity in feet per second. And we want to be able to use that to try and calculate the total distance this thing has traveled. And this is part of that fundamental basic idea of calculus. Does anybody remember, is this calculus 1 problem or calculus 2 problem? Integral calculus or differential calculus? 2. It's an integral calculus problem, and I'll explain more why once we do it. All right, so let's pop that into a new window. I need a screenshot of that table. So if you've already done this, cool. If you haven't, then I hope this helps. First thing, I'm a visual person. I'm going to graph this. Straight line tool. All right, so I need a vertical axis for the velocity and a horizontal axis for the time. And I'm going to need to mark it off. So let's see, 0, 1, 2, 3, 4, 5, 6. So black. 1, 2, 3, 4, 5, 6. When you do graphs for me, I highly recommend you put some numbers on the screen so it's clear what I'm looking at. Even if you always go 1, 2, 3, 4, which doesn't work all the time, feel free to tell me what the axis means and put a couple numbers. You don't need to label every single number. It's velocity. So what do we have? We got to get up to 30 in this case. So maybe I'll go by fives. 5, 10, 15, 20, 25, 30, 10, 20. All right, so the way I would interpret this one is starting at 0, it was going 16 feet per second. So 16 would be right here. And then at 1 second, this switches to 29. So that I just get that vertical bar there, holding constant velocity for a little bit. Then we jump up to 29, somewhere up here-ish. And then next second is 30, so just a tiny bit above that. 18, about there. 5, way down here. 2 is down here-ish. And then this is, since I started moving to the right, that 12 is going to be right beyond 6 with a 7 there. So that's right here-ish. So that's a graph of this thing's crazily changing velocity. What we want to find is distance. And recall distance is equal to rate times time if the rate is constant. In Calc 2, we'll look at what happens if the rate is more variable. In this case, my rate is the velocity, my time is called t. So for example, for the first second, let's call that distance 1. It was moving at a rate of 16 feet per second, true? For 1 second. Put the units in there just to show that the seconds disappear, leaving me with an answer of 16 feet. And what I pointed out in class on Tuesday was graphically what's going on there is the 1 second is that distance there. The 16 feet per second is that distance there. Multiplying those two gives me the area of that rectangle, which happens to be the distance traveled over that time, which is kind of cool. This wild relationship between velocity, distance, time, and area. So guess how I'm going to find the next distance? Yeah, 1 times 29, then 1 times 30, and 1 times 18, and so on. So the total distance here is just going to be the sum of those velocities times time. Now, since it's 1 second, it looks like I'm just adding the velocities, but I'm not, right? This multiplication is happening in the background. So my answer is going to be, the first time I answered this, I got it wrong, not because my arithmetic sucked that day, but because I included the 12 in that, but it said only for the first 6 seconds. That 12 takes us into the 7th second, which screwed me up the first time. So I had a great answer to a different question. So I only want those blocks right there. So I have to add up these numbers, but not the 12 in this case. What's that come out to? Oh, let's see, 15, 23, 30, 30, 40, 50, 60, 70, 80, 90, 100? What do you think? That's right. That's what you got too. Okay. I got this wrong 3 times in a row because the second time I tried to add in my head and I didn't add right. So I get it to 100 feet. So. And those were the 2 problems people had the most difficulty with, from what I've heard with people asking me questions and looking at your homework results. Did anyone have another question they got stuck on in this section?
Could you go over number 5?
Yeah, absolutely. Number 5. Oh yeah, this is a great one. Okay. So let's see. I am just going to grab a screenshot of all of it, I guess. New screen, Shot. Okay. So on this one right here, a ball is thrown into air by a baby alien in the system of Alpha Centauri with a velocity of 32 feet per second. That's either low gravity or very strong baby. A height of 15 feet, a height in feet after t seconds is given by that equation. So this is our height equation. Oh, and there. Find the average velocity for the time period beginning when t equals 2 and lasting that many more seconds. So question, is this number right here, remember we talked about h and 2 different x values the other day? Is this my change in time h, or is this a new time to look at?
H.
It is my change in time h, right? So what that means for this one right here, I want x equals 2.01. For the next one, I want x equals 2.005. For the next one, I want x equals 2.002, 2. And the next one, I want x equals 2.001. So it was similar to some of the problems you did before this one, but the ones before gave you the next x value. Here, I just gave you the change in x. Okay, Siler?
Yeah.
Good.
That'd be like finding the tangent, right?
Yeah, and so what we're doing is we're working our way toward the tangent line. Each of these is going to be a secant line, starting with the point 2, whatever y is, and ending with the point, this new x value, whatever its y is. So the procedure here is we're always going to start at t equals 2, comma, y equals, and we're going to have to plug that in. So I'm going to have to whip out my calculator.
So the h is already given.
And then the h is given right here. That's my h each time. Yeah, so I need to find the slope given that information. So we consider our slope formula for secants. One version of it is f of x plus h minus f of x all over h. The other version, I'm going to write it as f of, let's say, b minus f of a over b minus a. So you can choose either version to do this one. Okay, for the first one, I'll do it both ways to compare, and then after that, I'm probably just going to use this first version right there. So for the first problem, I need to calculate the slope by finding f of 2.01, subtracting f of 2, and then dividing that difference by 0.01. If you're using the other version of the slope formula, then you're going to have whatever the y value is at 2.01 minus whatever the y value is at 2 minus 2.01 minus 2. You see the relationship down there? 2.01 minus 2 that's the h they gave me before. Okay? And Kyler asked me about this problem the other day, and Kyler and I took this approach to do it, but you could do the other one. Okay.
Is it 0.01?
Oh, it's 0.01 here. Yeah, sorry, I missed a 0. 0.01. So I'm going to use Desmos to help me with this. Sometimes I do this kind of problem on a spreadsheet when I have to repeat the same calculation over and over again. So first I'm going to enter this in function notation. Desmos wants to use x, not t. It does something else with t. So what was this one? 32 equals 32x minus 13x squared. Did I get that right? Yeah. 20. Okay, 32 and 20. All right. So then I can do things like find out what is f of 2, because I'm going to need that y value. It's negative 16, so I'm going to put that in my notes. So y is negative 16. So there's my first point all of the time. My second point changes each time. So I got to start finding that. So I'm going to use a little trick here. I'm going to set a variable called h, sure. And h is going to be equal to 0.01. Not going to worry about stepping it, because then I can do things like say, what is f of 2 plus h? And so it'll automatically say, oh, you want 2.01. Is this too weird of a trick? Am I freaking anyone out? Not in the moment, okay. So it says it's negative 16.482. So then I can say, all right, I want the slope now. So my slope m is going to be equal to, I like to use parentheses, is going to be equal to that number above, f of 2 plus h, minus f of 2, divided by what here?
H.
H, cool. So now since I told it, if I change h here, it'll update h everywhere, which is kind of cool. So the computer's telling me that the second y value is negative 16.48. If you take the change in y, which would be this number minus that number, and then divide by h, you're going to get a slope of negative 48.2. So I'm just going to write that down more carefully just to double check. So my first point is 2, negative 16. My second point for part A is 2.01, negative 16.482.
Yeah.
My slope is then going to be change in y, so negative 16.482 minus negative 16, sign errors, be careful, these parentheses, all over the change, which was just the 0.01. So basically that takes the negative 16 away, leaving me with a negative 0.482 divided by 0.01. That shifts the decimal point twice to give me negative 48.2, which you can check on your calculator. And then we just need to keep doing that same thing over and over again. Replace 2 with 2.005. Get the y value, find the change in the numerator, divide by h, that'll give you the next slope. And just do that again. Okay. And I did a problem very much like this. Anybody like spreadsheets here? Just a few of you? Okay. So I did one like this on a spreadsheet the other day and recorded it for fun for someone. So this is what I do for fun on the weekends. Instead of kicking back with Netflix, it's me and YouTube. Hello, come on. So I did a recording of me doing basically the same problem, but in a spreadsheet, if you want to check it out. There's that one. This one right here. I do it on Desmos there too, I believe. Hey, that's me.
Welcome to Calculus Online.
That's weird, watching a video of me all in class. All right, anyway. Does that make more sense? Who asked that question before? Was it Vitor?
Kinda. Every time I do it, it just marks me wrong.
Okay, so let's check the next one and see what we get here. So the first one, I get negative 48.2. Now, since we're taking points that are getting successively closer, there should be a pattern to each of these numbers. We should see them heading toward the same place. So let's go to Desmos. And so all I have to do is change to my next h. Desmos tells me the next answer is negative 48.1. So where's that problem? Negative 48.1. Notice those two numbers are relatively close together. Next h was 0.002, I believe, negative 48.04. There's a pattern forming here. Think you see where it's heading? Negative 48 maybe? Yeah, so let's do that last one. I think it's 0.001, negative 48.02, excuse me. Negative 48.02. And so I'm guessing that the instantaneous velocity is probably going to be negative 48. Show me. This question has been submitted since you viewed it. I did not submit it. Oh, did I accidentally double click? Ah! Son of a gun. No. What the heck? Russian interference. Huh? I'm not enrolled in this course. Wait a minute. I'm the teacher. Oh my gosh. Don't you hate when that happens? Okay. I'm 90% sure I was right. Which problem was that? 5?
Yeah.
Yeah. Okay, so actually what I can do is submit it repeatedly and then it'll show me the right answers.
It's a different question.
Yeah, then it's it's the same idea though. So here I can see that it's a sequence of numbers heading in the same direction. So if you're doing the calculation, your numbers are getting wacky, that means, ooh, you must have done something wrong in the calculation. Maybe you missed a parentheses in your quotient. Maybe you missed a negative, but there should definitely be a pattern to it. And another nice thing about the homework, if you do it 3 times in a row and get it wrong, it will show you what the answer should be, and you can kind of try and backtrack and reverse engineer it. What was that, Vitor?
I forgot the negatives. Never mind.
Okay, yeah, and again, we all make those mistakes. I make them all the time. All right. This is a limit process, right? We are trying to approach what's happening at an instant in time, okay? And a speedometer is a measuring tool that does that for us, but algebra-wise, it's a little bit trickier. Okay? So I want to take a look at a problem we looked at yesterday and look at some new ones. So I'm going to move on to section 2. So don't need that page, don't need that page. Might need Desmos again. Let's hope it doesn't kick me out again. So limit of a function. Textbook, very informative. Some videos here. And we looked at a problem like this yesterday. Let's take a look at that one again. Okay, so this one is a little different set of numbers, x squared minus 16 over x minus 4. New page. So our function in this case is f of x equals x squared minus 16 divided by x minus 4. The limit value we're interested, I'm going to call that a is equal to 4. And so the question we're going to approach numerically is, what is the limit as x approaches 4 of this function x squared minus 16 over x minus 4? And sometimes I put parentheses around the whole thing like that. Sometimes I don't. It's just whether it seems obvious whether I'm taking the limit of the whole thing or not. I don't think I need parentheses in that case. Thing about a limit, what does this mean right here?
It means as x is approaching.
Approaching 4, right? So that language is pretty important. So x is approaching 4. Oftentimes, most of the functions we've seen in our lives and most of the numbers we plug into them work out really nice. So what's going to happen a lot, if you just randomly picked a function in an x value, you would find that the limit as x goes to whatever that value is of that function, it's probably going to be equal to whatever, if you just plug it right in. You don't worry about approaching it. Just let's get there, see what happens. So often with these things, I just say, let's just do that right away. What happens if you try to plug in 4 here?
You
get 0 over 0. Yeah, so in this case, we're going to find that f of 4 is equal to 0 over 0, and 0 over 0 is indeterminate. Meaning that sometimes there is an actual answer there. It could be 1, it could be 0, it could be 44. Right? Or it could be infinity, which is a direction instead of a number. So we got to play around and figure that out. One way to do that is just by making a list of values. So we could say, all right, well, let's just grab 4 and try to get close to it. So I could make a table here, blue, and I can't plug in 4 because it's undefined if I do that. So I have to try to approach 4. So approaching 4 would mean maybe start at 5 and then head toward it, 4.5, 4.1, 4.01. And you can pick any sequence of numbers you want that are getting close to 4. Now, the thing is, number line-wise, x equals 4 lives right there. Let's say 5 is over there. We're doing that approach right there. But there's another way to approach, right? I could approach from the other side. So what we end up with the idea of limits usually involves a right-hand limit and a left-hand limit. So on this side right here, what I'm doing is I'm finding the limits as x approaches 4 from the right side of this function. Over here, I would say I'm finding the limit as x approaches 4 from the left side. So we put a little plus or minus in the upper right corner of the number. Sometimes they match, sometimes they don't. Depends on the function. So anybody get a calculator out?
Yeah.
Help me out with this. So our function here is again x squared minus 16 over x minus 4. So what we need to do is start calculating these numbers and hope they form a pattern. So I'm going to whip out Desmos to help you with that. And let's get a new Desmos screen in case we need that one for something else. So f of x, and if you're using Desmos, this is nice. TI, you can do a similar kind of thing. You're kind of on your own with TIs. Unless you're really desperate, you can ask me. Divided by x minus 4. So that's my function right there. So what is f of 5? 9. What is f of 4.5? And again, in this problem right here, I'm ignoring the homework for just a moment. I'm just doing my own sequence of numbers. But usually in the homework, I'll give you the sequence of x values I want you to use. 4.1 of 4.01. And sometimes you do a few of them and you're like, aha, I see where it's going, right? Where do we think this is going? It looks like it's going to 8s. Other times it's not so obvious. You're like, oh, where the hell is this going? So the right side seems to be going to 8 from above, right? We're dropping down from 9 to 8. Other side, I would do something like what's f of 3, 7. What's f of, what should I use next? 3.5, 3.9, something like that. Trying to get close to 4. 7.5. Oh, looks like I'm heading in the right direction again. So you need to be the master of your calculator, getting used to using it to do repeated tasks. Let's see, 3.9. Yeah, I'm feeling pretty comfortable about the approaching 8 thing there. In the homework problem, in this case, I give you the numbers. So 4.1, 4.01, 4.001, 4.001. I'm going to skip those guys for now. You guys can fill that in your homework. But I'm pretty sure this limit is going to 8. And I'm just going to submit that part. It's going to mark me wrong on some stuff. Yes, thank you. I know it's incomplete. By the way, if you don't answer all the parts, it'll warn you, hey, you didn't answer all the parts. And you can either cancel and go back and answer them. All right. Yeah, so I got the limit right. That's mostly what I cared about at the moment. But a limit is about approaching a number, right? Sometimes you can cheat and just plug in. It just works. Other times you can't. Here it didn't work. However, does anybody notice a relationship between the numerator and the denominator here?
Factor.
It's a factor, yeah. X squared minus 16 factors, and one of the factors is x minus 4, because it's the difference of two squares. The numerator could be re-expressed as x minus 4 times x plus 4. And we have a factor of x minus 4 on the bottom. And we all know that a number divided by itself is 1. And multiplying by 1 is kind of lame. So 1 times x plus 4, we can say that this thing is equal to x plus 4. Now what happens if we cheat and try to plug in 4?
You do 8.
We get 4 plus 4 is 8. Ah, there's the answer. And is there always an algebraic trick to get that limit if it exists? No, there isn't always. But for your homework for now, there's almost always going to be an algebraic trick in there to get it. Okay? The question is, can we find that algebraic trick? Have we seen it before? Notice I put equals. Is it true for any value of x I pick that this answer will match that answer?
No.
There's one value they don't match at. Which one? 4. Yeah, they don't match at 4. Yeah, so these two are equal as long as x is not 4. Because this one says can't compute. This one says it's 4. But if you pick any other number, they're going to agree. Like, what if I plug 0 into both of these? If I plug x equals 0 into the top one, I get negative 16 over negative 4, which equals
4.
If I plug 0 into that one, I get
4.
4, yeah. So everywhere else, they just match perfectly. Yeah. So if you graph this and instead of getting some really crazy rational curvy function, it's just a straight line with a hole in it. Okay. All right, let's do another one. How about, there's a really cute one here. Oh, hey, check out the sequence of numbers here. Would you agree 2 is a problem here? I plug in 2, I get 0 over 0. So here we're approaching 2, 3, 2.5, 2.1. Is this the full limit or just a partial limit? Yeah, is it the left side or the right side? It's the right side, yeah. And so down here I ask, which limit are we finding in the table above? And you would say, oh, we're finding the right limit there. Okay. So read the fine print on these. Yes, I want to leave. That is not that bad. Oh, this is a cute one right here. Let's do this one. So here's the function. I'm actually going to do this one with all of the values. 1 plus x, in parentheses, to the power 1 over x. So get out your graphing utility, throw that in there. I'm going to screenshot this sucker to my notebook. How are we doing on time? We're doing great. Screenshot. And the number I'm interested in here is what happens when x equals 0. So I'm going to cheat right off the bat before I do the table and say, hey, what is f of 0 anyway? So that would be 1 plus 0 to the power 1 over 0. Ooh, darn it. I just divided by 0. My calculator's not going to be happy about that. Okay. A lot of times in math, 1 over 0 turns out to be infinity. So this answer is 1 to the power infinity. Hey, wait a minute. If you take 1 times 1 times 1 times 1, shouldn't that be 1? Just wild guess, question mark. Is this 1? I don't know. I'm just making stuff up right now. All right, so now we're going to start plugging numbers in. So I plugged the number in for you. I plugged in x equals negative 0.01 and x equals 0.1 into this, and my calculator told me that f was, the y value was that, 2.86797. Oh, interesting. It's the same thing on each side. Huh. Okay, so your goal is to start plugging in these other numbers, and I'll start catching up to you. So on your calculator. Yes, sir?
It's a really long decimal that you just put in the whole thing.
Yeah, good question. Sometimes on the homework, I'll say round to so many places. Other times I don't. So my usual strategy is I'll take it out to 4 decimal places when the computer doesn't tell me what to do and hope that's enough. So let's see, does this give us any fine print? No fine print here. I gave 5 numbers in this answer here, so I think I'm going to stick with 5 decimal places. All right, so let's get Desmos open. Clear out some stuff. Just clear everything. All right, so let's see. Correct. Oh, I need to use f of x equals parentheses 1 plus x raised to the power 1 over x. And, oh, check it out. So sometimes it's nice to just look at the graph. Doesn't the graph look like it's got a number at 0 right there? But we know if we try to plug in 0, we get a problem. Okay, so we just got to say what's happening when I get close to that. Okay, here's my sequence again. I'm just going by multiples of 1/10, okay? So f of negative 0.01, f of negative 0.001, f of negative 0.0001, and I think there was one more. F, that was the last one? There were only 3?
Yeah.
Okay. Okay, thank you. So 2.7319999, 2.71964, 2.71841. The numbers seem to be going somewhere. It's not as obvious as 8 was, right? But they're going somewhere. Let's check the other side. 0.01, f of 0.001, f of 0.000. I get enough there? 1? Okay. They look like they're going to a pretty similar place, right? The last in each group was 2.71841-ish. If we don't round that fifth decimal place or fourth decimal place.
Should we round?
I'm going to go with 5 decimal places rounded and see what happens. Yeah, and on this one, I think we're all going to get slightly different problems if I remember right. I think I programmed it so that sometimes it's a 1, sometimes it's a 2, sometimes it's a 3 up there. So you'll have slightly different answers. So I'm going to split my screen so I can type some stuff in. Actually, I'm just going to move that over to the other window. And actually, all I really care about is this right here. So I'm going to go to that last one. It says enter an integer or decimal, so it wants a rounded answer, 2.7181445. The other one
I would
was
stop at 2.718.
2.718. So let me bring this list of numbers back in here. So I'm looking at this last two. So 7181. Okay, so they're only matching up to that third decimal place. Okay, yeah, I'll take Sarah's advice. I'm going to go to 3 decimal places. I'm going to get marked wrong on the others, but I don't feel like typing them in right now. Yeah, I got that one right. Okay. Does anybody recognize that number, 2.718? Does that sound familiar to you? It's E!
Oh, it's you.
Woo! Yeah, check it out. If I go, what's E raised to the first power? 2.718, more stuff. Yeah, it turns out that is one definition of the value of E. There are other ways to define E. We'll talk about that later in the course. But E is a very special number. It's as special as pi. It comes up all over the place in the universe. Yeah. So sometimes we can guess at it. Sometimes it's just 2.718 for now, right? And if we want more decimal places, we just keep probing that limit. And sometimes it's the only way to do it. Okay? Just the way it is. We have 3 minutes. All right, let's take another cute problem. This one I'm just going to write on the board. And we are not quite done with 2.2. We'll spend more time on it tomorrow. So let's check out f of x equals the sine of x over x. So we're going to look at a couple of trig functions, and then the other thing in this section we need to look at are asymptotes. You guys remember those from previous math? So we're going to look at asymptotes as limits too. That's also in this section. All right, what the heck is the sine of x over x doing? Can you tell me what number you think is going to be problematic here?
0.
0 is going to be the problem, because the sine of 0 is 0, and if I divide by 0, I have 0 over 0. So the question is, what is 0 over 0 here? And last time I was predicting that 0 over 0 in this case might have been 1, but it wasn't. What was it instead? It was E, I think. I only have 3 decimal places, but that's pretty good evidence, isn't it? Okay. And we could search for more, but I'm pretty confident it's E for a variety of reasons. So, what's 0 over 0 here? It could be 0, it could be 1, it could be a half, it could be E, it could be infinity. You never know until you start playing. So, let's start playing with it. Whip out your favorite calculator. Yep. Oh, it's 11:50? Darn, it's time to end our fun with math. So, you guys get to play with this on your own. There are, I think, 3 homework assignments like this one. With other numbers thrown in there, like a 3 or a 5 or something. We'll play with this one tomorrow. Play with it in your homework. Have fun doing it. If a problem is totally vexing you, then hit message your instructor if you can't wait till the next day we meet, which happens to be tomorrow. So have a good day. Do good math safely. Breathe often. Sigh out once in a while. Catch you later, Carter. Have a good day.
Thank you. You've been super responsive to my questions.
Oh yeah, I tried. This is like one of my favorite math classes ever. Can